The first type of transformation we're going to look at is the translation. A translation is when you move a point, a figure, or a line left, right, up, or down. The first thing we need to do is get down some important vocabulary. So first off, we have the original figure or the original point, and this is called the pre-image. After you perform the translation, which would be moving the figure left, right, up, or down, that new figure is called the image. So on the graph here that you see, the pre-image is in blue, and the image is in red. For the first example, triangle ABC is the pre-image. The image is triangle A', B', C', and it's important here that when we read the new figure, those little apostrophes are actually read as A', B', C'. So here's our first example of actually performing a translation. We're going to translate the point A to 4. So I'm going to plot 2, 4. There it is. And we're going to move it 3 units to the right and 1 unit down. And that new point will be called A'. So if we take this point right here in yellow, and I move it to the right 3, so 1, 2, 3, and then down 1, our new point, which is called A', is right there. And we need to write the ordered pair that would describe it. So that ordered pair would be 5, 3. Now there's also an algebraic method which can be faster if you don't want to graph. So if you think about what's happening here, we had the original point, 2, 4. And think about if you move a point to the left or to the right, that's moving in the same direction as the x-axis. And so the coordinate that you end up changing is the x-coordinate. When you move to the right, the x-coordinate becomes more positive, and so it would be like adding to that coordinate. So we had 2. When I moved it to the right, I ended up increasing it by 3. So I add 3. And then similarly, when we talk about y's, the y-axis is the up and down direction. But when you move down, that's going towards negative y's. And so you take your y-coordinate, which was 4, and then we would subtract 1. So you'll see here doing the algebra, this gives us 2 plus 3, which is 5, and 4 minus 1, and that is 3, and they match. So here we can see a summary of the rules for what you do with the coordinates when you're moving a point. If you are going to move to the right, so to the right would be this direction, and this is the x-axis, and it's the positive direction, so we will add. So to the right, you add. If we would go to the left, that's the x direction, and it's negative, so we subtract if we're going to the left. If we move up, that's in the direction of the y-axis, and up is positive. So up means you will add to the y-coordinate. If we move down, down is towards the negative y's, and so we end up subtracting from the y's. So here we have a couple simple examples. So first one here, A23 is moved to the right 1 and down 4. Notice right here it says that a point is moved up 2. That actually belongs over here, so we can ignore that. Let me just copy it here. So I end up 2. Don't need that. All right, so A23. Let's see what's going to happen here for A'. So for x, we're going to move to the right 1. And again, x is to the right. And 1 means that we're going to have to add 1. So to the right is positive direction, so plus 1. And then we're going to go down 4. So down tells you that you're dealing with y's, and also that you need to subtract 4 from your original y coordinate. So our new ordered pair, 2 plus 1 is 3. 3 minus 4 is negative 1. If we look at the second example here, B was originally at negative 5, 2, and it's moved to the left, so we're going to have to subtract 6 from the x coordinate, and then up 2. So we were at 2, and up 2 means you're going to have to add 2. So your image is going to be at negative 11, 4. Now we're going to look at translating a whole figure, and we'll do this both graphically and algebraic using our rules. So if we take a look at the graph here first, we have the points A, B, and C, and I have already written off to the side here what their ordered pairs are. We need to take this figure and translate it 2 units to the left, and then 4 units down. So if I take A here in blue, 2 units to the left would be going back 2, and then 4 units down. 1, 2, 3, 4. So right here, that is A prime. If I move B, so we'll do B in green. Now B is kind of on a half, so it's going to be a little bit harder to move, but we can still do it. So 2 units to the left will be 1, 2, 4 down, 1, 2, 3, and 4. So there is B prime. And then C starts right here at 0, 1, 2 units to the left, 1, 2, 4 units down, 1, 2, 3, and 4. And so your new triangle would look like this. Normally when we write our answers, though, we do want to use the ordered pairs. So I'll just grab these ordered pairs off of the picture. So the new point A prime, that is at negative 7, 3, oh, negative 7, negative 3, sorry. And then here we have B. So again, B is at a half. It's a little bit harder to tell, but if I count over here, there's negative 1, negative 2, negative 3, negative 4. It's at negative 4.5, and that Y value is 3. And then C prime is located at negative 2, negative 3. If we use our rules, I'm just going to copy down here what our original points were. Okay, so 2 units to the left. That means we need to subtract 2 from the x coordinate. 4 units down means we need to subtract 4 from the y coordinate. So for A, negative 5 is the x. So we'll have negative 5, subtract 2 from it. And then for the y's, we had 1, and we need to subtract 4 from there. That gives us A prime as being negative 7, negative 3. And I look over here, they match up. For B, it would have been negative 2.5 minus 2 for to the left, and then 7 and minus 4 since it moved down. That gives you B prime of negative 4.5, 3. And again, that matches. For C, we would have had 0 minus 2 and 1 minus 4, and that's the point negative 2, negative 3. For our next example, we have triangle ABC is formed by the points A, negative 2, negative 5, B, 3, 1, and C, 5, negative 7. What is the image of the triangle if it is translated 3 units to the right and 2 units up? So I've already plotted the points. But 3 units to the right, that means I have to add 3 to the x, and 2 units up means I have to add 2 to the y. So if I write my original points, A is negative 2, negative 5, and to find A prime, I need to take those original values. So for negative 2, that's the x coordinate, I need to add 3 to it because it's being moved to the right. And then negative 5 was the y coordinate, and since it's being moved up, I need to add 5. So that means A prime, or the location of the image, would be negative 2 plus 3, and that's 1. Negative 5 plus 2 is negative 3. For B is located at 3, 1. To find B prime, I need to add 3 to its x and add 2 to the y. So B prime will be at 6, 3. And last for C is at 5, negative 7. C prime will be located at 5 plus 3 and negative 7 plus 2. That gives us 8, negative 5. So the important thing for you to notice here is that in every single one, because we moved to the right, I added 3. And then when we moved up 2 units, I've added 2. Graphically, we could check this. I'll check one point here instead of all of them. But if we take the point A here, and we go 3 units to the right, so 1, 2, 3, and then up 2 more, right there should be A prime. And so how is that point described? Like, what's the ordered pair? Well, the ordered pair there is 1, negative 3, and that's the same thing we got using the rule. Here's just a summary of those rules one more time. So if we move to the right, we add to the x, move to the left, subtract from the x, move up, add to the y, move down, subtract from the y.